Example 9, we want to find the exact value of cosine 15 degrees using a half angle identity. Okay? So we want to find cosine 15 using a half angle identity. So 15 is half of 30. So basically, we're changing it into 30 over 2. 15 equals 30 over 2, and that's what we're looking at. So look for the cosine half angle identity, and it's this one right here. So cosine A over 2 equals plus or minus square root of cosine A plus 1 over 2. So that's kind of our formula we're using. And a couple of things. Notice that A in this example would be 30. Okay? A would be 30, not 15. A is 30. Okay? Also, this plus or minus comes from the quadrant. All right? But we know what quadrant we're in because it's 15 degrees. 15 degrees is in quadrant 1. So that means that I would be using the positive version of this formula. Okay? So because we're in the first quadrant, we're going to use the positive version of this formula, and it's going to be square root cosine 30 degrees plus 1 over 2. It's pretty complicated, but we can get there. We know cosine 30 from our chart. Cosine 30 is square root of 3 over 2. So square root of 3 over 2 plus 1 all over 2. Really complicated looking fraction. And so there are a couple of different tricks you can do. The fastest thing is probably not the easiest thing. So what you should be trained to do at least is we're adding fractions. So get a common denominator and put those together. So we have square root of square root of 3 plus 2 all over 2, all this over 2. Okay? Now what I would do at this point is probably look at that as fraction, 2 over 1. And so I see that I'm dividing fractions. You should be trained what to do when we divide fractions is multiply by the reciprocal. And so that cleans up a bit into square root of square root of 3 plus 2 all over 4. That's 2 times 2 is 4. Okay, that looks a little bit better, but I can go one better because I know the square root of 4 on the bottom there. So I would have big square root of little square root of 3 plus 2. Notice that 2 is inside that square root. All over square root of 4 is 2. And that's your answer. Okay? So if I wanted to verify that, I guess you could type that into your calculator and see if that actually equals cosine 15. But that's what we're trying to do. Cosine 15 is exactly square root of 3 plus 2. Oops. Square root of 3 plus 2, all over 2. Example 10, we're finding the exact value of tangent 22.5. Okay, 22.5 is kind of a weird number. You should notice that. You should pay attention to that. But you should also notice that, oh yeah, that's half of 45. Okay, I know 22.5 is weird, but it's half of 45. And so that's why we're using a half angle identity. Okay, if I wanted to find tangent 22.5, it's nice to notice that 22.5 is half of 45. Okay, and so notice that A in this formula is 45. A is not 22.5. A is 45. And so we're using this identity with A equal 45. Tangent 45 over 2 equals sine 45 over 1 plus cosine 45. Okay, A is 45. So we've got a couple of things that we know from our chart. Sine 45 is square root of 2 over 2. And on the bottom, cosine 45 is also square root of 2 over 2. So we need to clean this up. The easiest step, I noticed the textbook does this, multiply by 2 over 2, and that cancels out your fractions. It's kind of hard to understand why they do that. So if you want to do that, do that. I think it's probably more obvious to get a common denominator here. Get a common denominator on the bottom, and you'd be looking at square root of 2 over 2 all over 2 plus square root of 2 all over 2. Okay?
And so anytime we divide fractions, we would multiply by the reciprocal. And you'll notice those 2's cancel out. And that's what's going to happen. So we have square root of 2 over 2 plus square root of 2. And it would be awesome if we were finished, but we all know that we can't have that square root on the bottom. We have to rationalize the denominator. So let's do that. Okay, in order to rationalize the denominator, we're going to multiply by the conjugate, 2 minus the square root of 2. So 2 minus square root of 2 over 2 minus square root of 2. And so I guess that's kind of messy. We're going to distribute here, and we get 2 square root of 2 minus the square root of 4, which is 2. And on the bottom, we're going to FOIL that together, but we also know something's going to cancel out. So if you know something's going to cancel out, if you know what, then go ahead and take a shortcut. Otherwise, we'll FOIL 2 times 2, 2 times this. We got minus 2 square root of 2. And then we distribute here, and we get plus 2 square root of 2 minus 2 square root of 4 there. And so maybe what you knew was going to happen was that was going to cancel out. And so on the bottom, we just have 4 minus 2 is 2. I'm looking at 2 square root of 2 minus 2 all over 2, which can be cleaned up even more because both terms in the numerator are divisible by 2. So basically, you divide both those terms by 2, and you're going to get the square root of 2 minus 1. Square root of 2 minus 1. So there's your answer. There you have it. Tangent 22.5 degrees equals the square root of 2 minus 1. We use the half angle identity, but to me the hard part's the algebra. All that canceling and common denominator stuff, foiling, all that stuff's algebra skills. Example 11 says given cosine s equals 2/3, and then they give you some information about where that angle is. Find cosine s over 2, sine s over 2, and tangent s over 2. We're finding some half angles, and this is there's one step in here that's kind of tricky. When you look at your cosine s over 2, let's do the first one. The half angle for cosine is going to be plus or minus square root of cosine s plus 1 over 2. Okay? Plus or minus means we're going to have to look at the quadrant, and that's a little bit difficult to do. You've got to really think hard about that. Okay? We are trying to talk about the half angle s over 2, but what we were given was information about the regular angle s. Okay? So like let's say s was 80 and we're looking at 40 or whatever. We're only looking at half the angle, and so the quadrant might not be the same as what they were showing us. So what we're going to do is we're going to basically divide by 2 so that we can look at the half angle. But we would divide everything by 2. Okay, divide all of those by 2 so that way we can look at the half angle. And that says 3 pi over 4 is less than s over 2 is less than pi. Okay? And that gives me some information about s over 2. It tells me what quadrant we're in. Okay? If you look at your quadrants, we know pi is here, and this is pi over 3 pi over 4 is like right here. Okay? 3 pi over 4. So when they say the angle is in between 3 pi over 4 and pi, they're talking about right in here. Or really they're saying the second quadrant. Okay? They're talking about the second quadrant. And so when you go back and look at, in this case we're talking about cosine, we know cosine in the second quadrant is going to be the negative version of this formula. Okay? We know cosine is negative, we know sine is positive, we know tangent is negative in that second quadrant. And so that's kind of the first step that you need to do, and it's a tricky one. A lot of people are going to forget about that step. Otherwise, we just start kind of rolling here. All right? We've got negative square root of cosine s, but cosine s was given to us as 2/3. So that's square root of 2/3 plus 1 over 2. So I would recommend getting a common denominator here. We're adding fractions. So we have negative square root of 2 plus 3 is 5 over 3 all over 2. And we want to think of that as a fraction, and when we're dividing fractions, we're going to multiply by the reciprocal. And so that cleans up a bit to negative square root of 5/6. At which point we're almost finished, but we would want to rationalize the denominator like usual. That's going to be this negative square root 30 over 6. Okay, so cosine s over 2 equals negative square root of 30 over 6. So then let's look at sine s over 2. Sine s over 2. So again, normally that's going to be a plus or minus square root of 1 minus cosine s over 2. But because I know we're in the second quadrant, I know that s over 2 is going, or sine is going to be the positive version. Okay? So I'm going to do pretty much the same thing. We've got positive square root, 1 minus cosine s was 2/3, all over 2. Get a common denominator there because we're combining fractions. And we would have square root of 3 minus 2 is 1/3, all over 2. That's a fraction, and we're going to multiply by the reciprocal in the same way as what we just did a minute ago. And that gives me the square root of 1/6. Again, we're going to rationalize the denominator, and we end up with the square root of 6 over 6. Square root of 6 over 6. So when I look at sine s over 2, that's the square root of 6 over 6. And so now let's do tangent s over 2. There are a couple of different things. The longer you go in these problems, the more options you have. And so, you know, maybe what I want to do is look at well, notice we have 3 options. We have 3 options for what to do for our formulas. But I would probably want to stay away from the ones with the sine in it, because I don't know anything about sine. I guess I could figure it out, but I would probably want to use the one that just had cosine in it, because this problem gives me cosine s was 2/3. So normally what I would do is I would look at this plus or minus square root of 1 minus cosine s over 1 plus cosine s, and just do kind of the same process. And you can, if you want to, or if you know that tangent s over 2 is equal to sine s over 2 over cosine s over 2, you've really got 2 different options. Option 1 is use that half angle identity, or option 2 is use our normal tangent identity with sine and cosine. I think the second way is easier, so maybe that's what I'm going to do. Okay. I know sine s over 2, I just found it, was square root of 6 over 6. And cosine s over 2, we just found that, square root of 30 over 6. So those 6's are going to cancel out. You can, I mean, if you want to think about it as multiply by the reciprocal, it's pretty obvious why the 6's cancel out. We have negative square root of 6 over square root of 30. And we can rationalize that. Actually, we can reduce a fraction. 6 goes into 35 times. Because you know you could reduce that way. But I'm looking at, what's that going to be? Negative square root of 1 over square root of 5 now. Okay, let's rationalize. This isn't the only way of simplifying, but it's one way of simplifying. We have negative square root of 5 over 5. And so tangent s over 2 is negative square root of 5 over 5. Example 12, simplify each expression. What you want to do is you want to try and look for the identity that looks like this. Okay? So when I look at part A, it says plus or minus square root of 1 plus cosine 12x over 2. Try to find the identity. Look at your formula sheet or look on the board and try to find the identity that looks like that. And you should be able to come up with the one that says cosine a over 2 equals plus or minus square root of 1 plus cosine a over 2. Okay? That's the one that looks like it. Okay? And so if you compare, then this must be A, right? 12x must be A, or right here. A is 12x. And so if you know that A is 12x, then look at the left side of that identity. It says cosine 12x over 2. And cosine 12x over 2, just clean that up. That's cosine 6x. These problems don't have to be that difficult. Okay? You just have to find the right pattern. When I look at part B says 1 minus cosine of something over sine of something. And so find that identity. That identity says tangent A over 2 equals sine A over, wait, that's not the right one. 1 minus cosine A over sine. Okay, that's the one that this looks the most like. And so as you're comparing what you've got to the identity, you would notice that A is equal to 5 alpha. So, you look at that left side says, tangent 5 alpha over 2. And nothing really, you can't really reduce that fraction, so that's it. Suppose you could call that 2.5 alpha if you wanted tangent 2.5 alpha, but I don't know that we want to do that. So that's it. All right, verifying an identity. We love these. So let's look at this one. We always want to start on the more complicated side. I think that looks like the left side. And if you notice, you've got a quantity being squared. So what we'll want to do is basically foil that and kind of expand that out. So we'd have sine x plus 2 plus cosine x. I think I said plus 2, x over 2 times sine x over 2 plus cosine x over 2. We're just going to FOIL that out. So double distributive property, we're going to have sine squared x over 2 plus sine x over 2 cosine x over 2 plus another sine x over 2 cosine x over 2 and plus cosine squared x over 2. I see some like terms here and here, so I'm going to combine those together. I have sine squared x over 2 plus 2 sine x over 2 cosine x over 2 plus cosine squared x over 2. All right. So at this point, I've really got two different paths I can go by. I see a whole bunch of half-angle identities. I can use those. Probably the easier thing to do is if you recognize and see that there's a sine squared plus cosine squared in there. That's probably the easiest thing to do. So I'm going to show you the hard way first, and then I'm going to come back and show you the easier way. Let's say we didn't notice the sine squared plus cosine squared in there. We just see a whole bunch of half-angle identities. And so what I've got is a half-angle identity squared plus 2 times a half-angle identity times another half-angle identity plus a half-angle identity squared. And so you look at the sine, the half-angle sine, it says plus or minus square root 1 minus cosine x over 2. Okay? And so what's going to happen is you would need to know the quadrant normally because of the plus or minus thing, but because it's squared, it's always going to end up positive anyway. So that plus or minus is going to go away when it's squared. In fact, the square root is going to go away when I square it, just leaving me with 1 minus cosine x over 2 there. So then I've got 2 sine, okay, wait a minute. I'm not going to use half angle identities here. I've got 2 sine x over 2 times cosine x over 2, and that looks like the double angle sine formula. Okay, this is the double angle identity for sine, and so we're going to call that sine 2. Normally it would be 2a, but our angle here is x over 2. And so sine of 2 times x over 2, the 2's cancel, and I get sine x, so plus sine x. And then over on the right side, you've got the cosine half angle identity. So that would be plus or minus square root cosine x plus 1 over 2. And again, like the other one, when that gets squared, okay, when that gets squared, the plus or minus square root goes away. And so we have plus cosine x plus 1 over 2 there. Okay. So a strategy that comes up every once in a while is splitting a fraction. So there, when we have 1 minus cosine x all over 2, it helps to split that into two separate fractions. And likewise over here, it's going to help if you split this into two separate fractions. Don't really need to do anything with this sine x just yet, but we'd have 1/2 minus cosine x over 2 plus sine x plus cosine x over 2 plus 1/2. And what's going to happen, a couple things will happen. One thing you notice is those things cancel each other out. And you also have a 1/2 plus a 1/2 is 1. You have 1/2 plus 1/2 is 1. And then this plus sine x comes down. You get 1 plus sine x. And if you notice, that's exactly what we wanted. Okay? We're trying to prove that the left side equals the right side. And that's what we did. That's what we got. And that's it. So now, I'm going to show you a different way. I'm going to show you maybe an easier way, I suppose. I don't know. We don't have to use those half angle identities. So let's go back to where we were right about here. If you had noticed, this said sine squared x over 2 plus cosine squared x over 2. We know sine squared plus cosine squared equals 1. And so those two things together would equal 1. And then we still have this double angle identity. And that double angle identity is the double angle sine identity. We have sine 2 times x over 2, just like we did before. And those 2's cancel. I'm going to have 1 plus sine x right there. That was a lot quicker. Okay, that's a lot faster. Maybe you didn't recognize that, but that's exactly where we're trying to get to. 1 plus sine x equals 1 plus sine x. Left side equals right side. 2.